All right, so as promised, I want us to look at some questions today, and I wanted these questions to be more like the questions you'd see on a test. So we have a bit of practice because, again, if you can see the questions for a topic in all the ways that they can be written, you'll be comfortable. All right, so let's start off with this very first question of 4, and it reads, if x plus 2 is a factor of f of x is equal to 2x cubed minus 3x squared minus 4x plus a, find the value of a. Alrighty, people. All right, first things first, we have a key bit of information here in the fact that I said that x plus 2 is a factor. And that's a factor. Using remainder theorem, we know that whatever value causes our divisor when equated to 0 to give you 0, right? Whatever value of x makes our divisor 0, when substituted into our polynomial is going to give a remainder, right? So essentially, what is our 0? Our 0 or root in this instance is going to be x plus 2 is equal to 0, which implies that x is equal to negative 2, and this is the value we're substituting into our polynomial. And because it's a factor, we know that once we substitute, we're going to get a remainder, but because it's a factor, that remainder is going to be 0. All right, so that means that 2 times negative 2 cubed minus 3 times negative 2 squared minus 4 times negative 2 plus this a is equal to 0. We're all on the same page. All right, so what's our next step? Well, we're going to just evaluate what we have. Now, negative 2 cubed is going to be negative 8, so we're going to get 2 times negative 8 minus 3 times negative 2 squared, which happens to be positive 4, minus 4 times, negative 2 times negative 4, or negative 4 times negative 2 is going to give you a positive 8 plus a is equal to 0. We're on the right track, right? So let's just continue and simplify. So we end up with negative 16 minus 12 plus 8 plus a, wow, is equal to 0. This is negative 28 plus 8 plus a is equal to 0. Of course, that's going to leave us with just a negative 20 plus a equal to 0. Therefore, a itself is going to be equal to just 20. So that is our value of a. Now, how much would a question like this be worth? I'm assuming it's a simple substitution, and I guess you have to do factor in understanding the concept and getting a final answer. So I'm assuming maybe 3 marks. Let me just check. Well, just 2 marks. So if there's an examiner marking this, they're going to mark you for your working and your answer. And I guess the logic is going to be wrapped up in that. You'd get a mark for the answer of 20. You get, I guess, a mark for the logic and calculation. It could be a 3-mark question, to be fair. Just 1 mark for acknowledging the fact that factor theorem here implies that once you substituted, that the result is going to be 0, right? But that is our first question. All right, let's take a look at our second question of, how many did we say? 4? All right, cool. Let us take a look and see what that looks like, right? All right, so this question, we're going to need some space when we're working, is saying let f of x equal x cubed minus x squared minus 14x plus 24. And you need to use factor theorem to show that x plus 4 is a factor of f of x. All right, so we just did that, so that process should be simple. Once you've done that, determine the other linear factors, right? We're going to get to that portion, right? Now, for the first part of that question, we know what to do, right? They said to you, essentially, show that x plus 4 is a factor. Now, if x plus 4 is a factor, then when we find the 0, that value of x that makes that divisor 0, and we substitute that value into the polynomial, we have to get 0. Long and short of it, right? So that's our very first step. What is our 0? Now, our 0, as you know, or our root, which is a term that we're going to use a little bit more when we talk about quadratics. Our root here is going to come from the fact that x plus 4 is being equated to 0, which means that x itself is going to be equal to negative 4. That is the root. Now, all we have to do to show that this is a factor is substitute that root or 0 into our function. If it gives us 0, then we've proven it, right? So we're going to say negative 4 cubed minus negative 4 squared minus 14 times negative 4 plus 24. And we need to find out that value, right? So for negative 4 cubed, we have a negative cubed, which is going to give us a negative 4. Cubed itself is going to give us 64. We'll have minus negative 4 squared, which is just 16. Then we're going to have minus 14 times negative 4, negative times negative positive. 4 times 14 should be 56. 4, 4, 16 should be. And then we're adding to that 24. All right, we need a bit of space. Let's see if we can get some space here. All right, scrolling up a bit. We should be about right there. There should be enough space for us, right? All right, so let's simplify if we can. All right, what can we add to make life simpler? Well, we can add negative 64 and 24. That's pretty straightforward. That should give us just negative 40. And we can add negative 16 and 56, and that should give us positive 40. And those two add to give us 0. So we've done the very first part of what we're required to do. Because having substituted our 0 into this function, then we've gotten 0. That means, therefore, the divisor that we had, which was x plus 4, is a factor of f of x. Do you have to write the statement? I would suggest writing the statement, because it shows that you've made that connection and you're not just working by rote. And you get the benefit of the doubt. And I think that's very important in exams when you're actually answering questions, to kind of give the examiner an idea that you understand what you're doing, because again, they're human, they're marking your paper. Once they believe and they've been given the impression that you know what you're doing, then they're more inclined to give you the benefit of the doubt going forward through the examination. All right, so little statements like this do make a difference. All right, second part of the question says, if you recall, was determine the other linear factors of f of x, right? So we know that x plus 4 is a factor of our original polynomial. F of x was x cubed minus x squared minus 14x plus 24. Now, this is a throwback to what we did before. If we want to find the other factors, this is a linear factor in x plus 4. This is a cubic term here. We could just divide the cubic term by the linear term, get our quadratic, and factorize. That's all we're going to do. Now, the form of our divisor here is x, 1x plus a constant, so we can use synthetic method really quickly to knock this out, right? Now, if we're using the synthetic method, the very first step is to find your root again, but you already know the root, but I'll write it down. X plus 4 is equal to 0, of course, implies that x is equal to negative 4. We drop our negative 4 here, drop our synthetic method lines, and we drag down our coefficient. So we have 1x cubed, negative 1 as a coefficient there, negative 14 as a coefficient of x, and then we have our constant 24. Now, because this is a factor, we expect that the last term that we're going to get here is a 0 in the synthetic method. But whatever is left here in terms of the terms, those are going to give us the coefficients of our quadratic. So the first step, bring down that 1, right? Then multiply and add always. So multiplying by negative 4. This is going to give us negative 4, and then we're going to add. We're going to get negative 5 here, right? Multiply by negative 4 again, right? We should get, looks like positive 20, right? And when we add these two together, that looks like a 6. Multiply by negative 4 again, and the expectation is that we have to get negative 24, which we do get in this case. We end up with a 0, and that is expected. And now we have our quadratic. Our quadratic is going to be x squared minus 5x plus 6. Now, I don't want to take for granted that you remember how to factorize, so we're just going to write this out first. We're going to write out that x cubed, because if you're not sure what the next step is, at least write out this step, because you can get marks here. Your examiner won't be lenient enough to give you full marks for this, but you will get something. An acknowledgement that x plus 4 multiplies the quotient that we just got. to give you this full value for f of x. So this is a factorization. Now, is it the full factorization? No. Right? Let us factorize that last quadratic really quickly, right? We can factorize quadratics. We're familiar with the concept, right? I'll just kind of reiterate, kind of go over it right now. We have x squared, and in order to factorize x squared minus 5x plus 6, I need to get two terms in x in the middle here that, thank you, this is my dog background. Two terms in the middle here that will sum to negative 5x, but have something in common with both the 6 and the 1 on either end, right? The coefficient of x squared and a constant, because in that way we have four terms, and those four terms can be, the two middle terms can be written in any order, and the factorization becomes basic. Now, to get the two middle terms, we're going to say, okay, when I multiply the coefficient by the last term, I get 6, right? 1 times 6 is 6. What are the factors of positive 6 that sum to negative 5? And we know that the only way to get a positive term is if we're multiplying a positive by a positive or a negative by a negative. So we need a positive times a positive or a negative times a negative that sums to negative 5. So we can go either 2 times 3, but that will give you a positive 5, or we can go negative 2 times negative 3 that sums to negative 5. So instead of having x squared minus 5x plus 6, we can go x squared minus 2x minus 3x plus 6, and then we factorize. What's common here? X, and that leaves x minus 2 in a bracket here. I can also factor negative 3 here, and I get x minus 2, which means my complete factorization is x minus 2 times x minus 3. And as our overall term, we'll end up with, if I remember correctly, x plus 4 times x minus 2 times x minus 3. And that is all equal to f of x. And f of x was initially x cubed minus x squared minus 14x plus 24. And this is our final answer. This is what we're looking for. And we're all done with that question. Now, that question would have been worth, and I'm checking to see, about 5 marks. So it's a lot of work for 5 marks. The first 2 marks would have come from just proving factor theorem, and the remaining 3 would have come from you dividing, whether using polynomial long division or synthetic method, and getting your quadratic and then factorizing. So, I mean, that could be worth more marks, but standard minimum, we'd expect it to be worth 5 marks. All right, second to last question. You're almost there. You're doing pretty well. Hopefully it gets easier. Let's see. All right, so this one reads, when the expression 2x cubed plus ax squared minus 5x minus 2 is divided by 2x minus 1, the remainder is negative 3.5. Determine the value of the constant a. So one thing ugly about this question is the remainder. We should be able to work though. So let's see if we can work. All right, let me get there with you. All right, so what we need here is, let's say we're dividing by 2x minus 1. And that means that our root or our 0, let's say that our 0 or our root in this instance is going to be 2x minus 1 equal to 0. And when we factor that, it's going to be 2x is equal to 1, which implies that x is equal to a half, right? Now, if that is the case, right, when we substitute that into our polynomial, the remainder is negative 3.5. So that means that 2 times a half cubed, that's a 3, I promise, plus a times a half squared minus 5 times a half minus 2 should be giving us negative 3.5. Right, 3.5, we could write this since it's a decimal, we could convert this. But let's work this out first, and then we can convert this either to a fraction or a decimal on either side, depending on what's easiest, right? So a half cubed is going to be an eighth, right? It's a half times a half times a half. Multiply the numerators across, multiply the denominators across. So we get 2 times 1/8, So we have a quarter there. Then we have a half squared here, which would give us a quarter on its own. So that's a times a quarter minus 5 over 2, because 5 over 1 times a half is 5 over 2, minus 2 is negative 3.5, or negative 7 over 2. We can just do that, right? All right, so let me get some space, and then we can just simplify and solve. We're almost there. So we should end up with a quarter here. We'll have a over 4 here. We have, and I guess we can call this 10 over 4 if we need to. We can call this is 2 over 1, so we can call this 8 over 4 as well, and we can call this negative 14 over 4. Now, why would I do that? If I express everything as a term over the same denominator, then I can just work with the numerators, right? So I really have 1 plus a minus 10 minus 8 is equal to negative 14, which I think is way easier to use. Now, why did I do that? Or how did I get to that point? Well, I've written everything over the same denominator. I had 2 over 8, which is a quarter. I have a over 4. I had negative 5 over 2. And if I want to write this as a term over 4, if I multiply the denominator here by 2, I have to multiply the numerator by 2 to keep the value of the fraction. So I end up with 10 over 4. And I had 2 over 1. And the same premise applies here. If I multiply this by 4, I have to multiply this by 4. So negative 2 over 1 is the same thing as negative 8 over 4. And again, to convert negative 7 over 2 to a fraction over 4, multiply the denominator by 2. And to maintain value, multiply the numerator by 2 as well. So we end up with negative 14 over 4. Now, if we wanted to get technical, I mean, apart from saying that the denominators are the same, and so we can just work with our numerators, you could technically look at this as multiplying all these fractions by 4, and in so doing, canceling out the denominator. So we end up with our whole numbers, for lack of a better term, in 1 plus a minus 10 minus 8 is equal to negative 14. We get 1 plus a minus 18 is equal to negative 14. We get a minus 17 is equal to negative 14, because 1 minus 18 is going to give you that negative 17, or I don't say minus 17, because a minus is an operation, whereas a negative is a sign of quality, or term that expresses quality. So here we can write this as a is equal to, and I'll just write that step, negative 14 plus 17, and so a is going to be equal to 3, right? So that's our final answer. Now, how much would this be worth? Let me find the question. This is just 3 marks. And to be fair, that is not a far shot from what you should get. Essentially, you're just maybe a mark for identifying the fact that, when you substitute, you get a remainder, and that remainder must be negative 3.5. And then everything else is going to be a mark for working and a mark for your final answer. So your final answer being 3 would give you that final mark. All right, we're almost there. I don't want to stretch this out too long. You've been doing well to this point, to stick around, stick and stay. Also, remember, you can always pause when we start a question, work ahead of us. I'm showing you the question now. Once you get this on your screen, just pause, work ahead, check to see whether or not you can get the answer, whether the process works for you. If you have questions, of course, you can leave them in the comments. But the important thing is for you to be comfortable and to practice. All right, so let's get this last question, right? It says, given that x minus 2 is a factor of k of x is equal to 2x cubed minus 5x squared plus x plus 2, factorize completely. We did this before. So after a while, what you'll notice is the more questions that you do, there are just so many ways that a question can be written. And so there are no surprises, which again is why I'm focusing on practice, because that's what math is about. The answer is great, but you recognize that when we do the marking breakdown, your answer is 1 mark, right? And you very seldom are going to get a 1 mark question. So your answer is never really going to be the fullness of what you get on a test. If you understand the theory, you can apply the theory. That is going to be where the majority of your marks lie, and your job is going to be to avoid simple mistakes. All of us make them. I will make them. The important thing is to understand what we're trying to accomplish. All right, cool. Let's get to it. So we said again, x minus 2 is a factor. When we say factor, we have it. We know what we're doing because guess what? Factor means that the remainder is 0 once we substitute that root into it, right? We know that. So they give us k of x. So all we have to do now is find our root. That's our starting point as usual. X minus 2 is equal to 0. That means our root is going to be 2. When we put 2 into this function, we have to get 0. That's all it is, right? Yeah. So given that this is a factor, factorized completely, well, do we need to do that step? Because we already know that this is a factor. They said given that this is a factor, factorized completely. I feel like, well, let's do the step. Let's prove that it's a factor, right? So here's our proof. Do you need to write the words proof? Nope. I'm just being extra. So it's going to be 2 times 2 cubed minus 5 times 2 squared plus 2 plus 2, right? What is that equal to is what we're working on now, right? So it's going to be 2 times 2 cubed, 2 times 8 minus 5 times 2 squared, which happens to be 5 times 4, plus 2 plus 2. Is that what we're seeing? Yeah, look like it. Plus 4. That's going to be equal to 16 minus 20 plus 4. And we already can see that we've already shown that, so we're almost halfway there. This is just going to be 20 less 20, which is 0. And we're good, right? Now, I think synthetic method should work here. Why am I saying that? Well, at this point, having done enough of these with you, oops, have I lost the question? Of course, that's what I do. All right, getting you back to the question. All right, we're right here now. Having done enough of these, all we need to know is what the divisor is essentially. Our divisor is, we just had it there, and did I just lose it? I may have. The divisor seems to have been x minus 2, right? Let me scroll up. X minus 2 is our divisor. All right, so let's write that down. Let me just transfer that. So 2x cubed, we said, we're dividing by, let's write it down here so I can see it for myself. Minus 5x squared plus x plus 2. Minus 5x squared plus x plus 2. And I'm pretty sure it's divided by x minus 2. All right? Yeah. All right. Check in. Yep. All right. So if that's the case, I'm just going to use the synthetic method because the coefficient of x here is 1, and that can be done. So really quickly, we know our root. Our root in this case is x is equal to 2. We drop our 2 right there. We drop our lines for synthetic method. We bring down our coefficients 2, negative 5, 1, and 2. Bring the 2 down. And then all we're going to do is multiply and add. So multiply by 2. We're going to add here. We're going to get negative 1. Multiply by 2. We'll get negative 2. We're going to add here. We'll get negative 1. Multiply by 2. You get negative 2. And we get 0, which we expected. Right? Now, if that is the case, that simply means that our answer coming from this line is going to be, since we divided a term in x cubed by x, 2x squared minus x minus 1, and cannot be factorized. Well, yeah, it can be factorized, right? And as a matter of fact, to be fair, and we spoke about the substitution, did we need to do the substitution? To be fair, no. Because if we did synthetic method or long polynomial long division, once the remainder was 0, we would have proved that it's a factor. So that first substitution was unnecessary. We could have just went straight to polynomial long division or synthetic method. So all we need to do now is factorize this expression here. And again, we're going to write this as 4 terms based on the fact that the product of the first and the last term, the coefficient of x squared and the constant, is negative 2. And we can find the factors of negative 2 that sum to give us negative 1, which is in the middle. We could use negative 2 and positive 1, which means that this can be rewritten as 2x squared minus 2x plus 1x, or plus x minus 1. And we can factor 2 terms at a time. What's common to these two? 2x as our highest common multiple. What's left is x minus 1. I can factor out 1 here, and what's left here is x minus 1. And we'll end up with 2x plus 1 times x minus 1. which means our overall factorization, if I remember correctly, I think we divided by x minus 2, right? The overall factorization is going to be 2x, wow, 2x plus 1 times x minus 1 times x minus 2. And that's what they're looking for. All right, gentle people, you stuck it out. Proud of you. We should have more questions. I'm going to stick to just test type questions and speaking to you about how marks are allotted. I didn't mention the mark scheme on that one. Let me just check. It should be like worth 3 on that one. That looks like a 3-mark question. So yeah, you'd have gotten a mark for either the long division or synthetic method, and a mark for the factorization, a mark for the final answer. All right, don't forget to like and subscribe, and when we get back in here, more questions. We'll finish up with some test questions, and then we'll move on to quadratics.